This lesson uses the slides taken from A4, and this is just a short introduction to proportions to help kids solve equations using complicated fractions when there is a variable involved. Now, the kids quite often learn how to solve proportions by using cross multiplication, which is a good method if the fractions are simple. When the fractions become more complicated, the work becomes more complicated. So we start the lesson using the multiplicative identity, which asking the kids, if I have a number and I want to keep the value of that number the same, what can I multiply by? Eventually the kids realize that you can only multiply by 1. When we multiply by 1, we get the same number and we get the same value. We want to stretch the kids a little bit by asking the question, if I have a number and I want to keep the value the same, what number can I use that will change the number? Now, initially this is a very complicated question for the kids because they're not used to thinking of ones in terms of that. But again, thinking about if I have a number, for example 4, and I want to keep that value the same, then what can I multiply it? Well, we've just discussed the fact that they can only multiply by 1. Eventually the kids, after discussion, realize that they can multiply by 1, but the 1 is going to be a fraction this time. So for example, in this case, we have 4 times 2 over 2, which equals 8 over 2, which equals 4. Or I could use a different 1, as in 3 over 3. So 4 times 3 over 3 gives us 12 over 3, which the value is still 4. From here, we take off to another part of the lesson, which the kids don't necessarily see that it's related. But what we're looking at here is if I have a value, or if I have an unknown, which is x over 3, which equals 1 over 3, what is the value of x? Quickly, the kids realize that x equals 1. If I have another number, 2 over 5, which equals an unknown over 5, what is the value of x? In this case, obviously, the kids realize that x equals 2. In the last case, we have 4 over 7 equals x over 7. Again, the kids realize that x equals 4. Now, when we're looking at this, we discuss then the fact that we know that the values of x are determined very easily because the values of the denominators are the same. Since we have common denominators and the fractions are equal, therefore the numerators also have to be equal. We move on to the same kind of idea where we have 1 over 7 equals 1 over x. The kids again realize that x is 7. And 3 over 16 equals 3 over what? X is going to be 16. Again, relating this to what we did above with the common denominators, we can do the same thing with common numerators. Now, this is pretty easy, and again, the kids often want to use cross multiplication to solve this. In this case, we realize that cross multiplication actually can make the problem more difficult when it's very simple to look at it and recognize that if we have a common denominator or a common numerator, then either the numerators or the denominators will still be equal. In the next slide, I give them something that's a little bit more complicated, where 5 over 9 equals x plus 3 over 9. Now, from the previous examples, they recognize the fact that the denominators are the same, so the numerators have to be equal. Since the numerators have to be equal, 5 will equal x plus 3. X then would be 2. Then I give them the equation 1 over 5 equals x plus 2 over 10. If I have x plus 2 over 10 and I can make a common denominator, this is where the previous lesson of the multiplicative identity comes in. If I multiply by 1, or in this case 2 over 2, my denominators become the same, making the problem very easy, because then I have 2 over 10 equals x plus 2 over 10, and x equals 0. This is the problem that I gave the kids in class. It is very challenging, but the kids were able to do it really relatively easily. The original problem is 4 over 20 equals 3 times the quantity of x plus a negative 11, or x minus 11, over 60. then the kids know that now they have to make the denominators the same. This step is very, very easy for most of the kids because they quickly realize that they again are going to multiply by 1, and in this case that 1 equals 3 over 3. When they multiply by the 3 over 3, the 4/20 turns into 12/60. We then have 12/60 equals 3 times the quantity of x minus 11 over 60. We can now just ignore the denominators, and then we move into a simple problem of 12 equals 3 times the quantity of x minus 11. Many of the kids in class at this point recognized that 12 equals 3 times what, and they knew that the what was going to have to be 4, and they simply jumped to, well, what minus 11 equals 4, and they went to the 16. Some of the kids went through the work to do the actual solving of the equations. Now this is an example of what I really would like to see from the kids, is that they draw a wall on the equal signs. It seems like an unnecessary method, but what I found is that the wall actually helps the kids keep their work organized, and then they recognize that whatever they have happening on one side of this line has to equal what's happening on the other side of the line. After they do the distribution property here with the 3 times the quantity of x minus 11, they end up with 12 equals 3x minus 33. If they determine that they want their x's on the right-hand side of the equation, they're going to have to eliminate the numbers that are on that side, which is a negative 33. In order to get rid of a negative 33, they have to add 33. What they do to one side, they've got to do to the other in order to keep that balance, the equation balanced. So they add 33 to both sides. That gives them 45 equals 3x. Now we have 3 x's, but I only really want to know what the value of one of those x's is. In order to turn 3 x's into 1x, I divide by 3. If I divide one side of the equation by 3, I have to divide the other side of the equation by 3. That gives me x equals 15. Most of the equations that we will be dealing with in this class are going to be very similar to this. Now, this may be a complicated problem, but we did this in class, and most of the kids were able to walk through it. Their homework will be very similar to this. If the kids run into an equation on their homework that they don't understand, please just have them give me a call or come in before school, after school, or again, I'm always available via email.